EKS or using Amazon ECS to deploy your application. You will also understand how to use AWS Copilot to deploy and operate your application into Amazon ECS and AWS Fargate, as well as understand how to extend the system to implementing CI/CD. So many fun stuff today, and let's get started. Let's first talk about containers and how we can do development with Docker. When we build application, in order to have our app runs properly, there are a couple of parts that we need to integrate. As you begin working with your applications, you start to realize that applications are not just code. They're built on other components that we call dependencies. Now, these dependencies include the runtime that executes the application code. And say that you're running the Node.js runtime. You may also need to pull in the JavaScript packages via the NPM. Further to the runtime and packages, there's often an operating system package that the application is dependent on that we need to manage also. And so one of the key benefits of containers is that they're able to convert applications into a single deployable artifact. They take the application code along with all of those dependencies like runtime, libraries, and configurations, and package them together into something called as a container image. And once that you have the container image, you can consistently and easily run the application anywhere as long as there's a container runtime. So let's jump into a demo where I will show you how to package your app with containers and run the application. In this demo, I'd like to show you on how we could package our applications with Docker and how to run the containerized application. Just a quick overview on what kind of application that we are going to deploy today. The application that we are going to deploy is a simple application to return HTML based on the markdown text that we pass as input. So the application will convert the markdown text into HTML using HTTP post method, and we can use the output. This is the structure of the application. We have the source code for this application, and the application itself is written on Python and running on Flask framework. I'll cover more details on the next demo. Once that you have your application ready, the next thing that you need to do is to structure the Docker file. A Docker file is a text document that contains all the commands a user call on the command line to assemble an image. And what you see now is the Docker file of the application. Let me briefly share with you the Docker file instructions to successfully build the container image for this application. The from instruction initializes a new build stage and sets the base image to Python 3.8 as the application is running on Python. The copy instruction copies the app.py and requirements.txt as those are the files required in the next instruction. The run instruction will execute pip install, which will install all libraries required to run the application. Then, the expose instruction informs Docker that the container listens on the port 9090 at the runtime. And lastly, the cmd is the command to execute the container. In this case, I'm using Unicorn to run the application. Once that we have the Docker file ready, the next thing that we need to do is to build the image. We can do this by running docker build. This will create the container image with the tag. And we list down the images, we will see it's created. And if you run docker run and exposing the port, it will run the application. And if we test it by passing the input, it returns the HTML response. So it works, although it's still running only on the local host. Okay, so running a single container is easy, like what we've just seen in the previous demo. But in reality, we often need to deploy more than one container. And things could become more complicated, as in practice, we also need to deploy to several different environments, like UAT, staging, or production. And not only the environments, depending on the workload of our application, we probably need to deploy to tens, hundreds, or thousands container instances, especially for developers who are adopting microservices. So what's the solution for these challenges? you need a tool that can automate your container lifecycle on top of managing your infrastructure. And this is the perfect transition for us to take you to the next segment, that is AWS services that you can use to do development and deployment at scale for container application. Choosing the right container orchestrator is a key integration point, as it will deeply influence your future development. And one of the most common requests we hear from developers is, help me to decide which container orchestration service to use. AWS has a set of fully managed container services, including Amazon Elastic Container Service, or in short, Amazon ECS, and Amazon Elastic Kubernetes Service, or Amazon EKS. Both services support a broad array of compute options, have deep integration with other AWS services, and provide the global scale and reliability you've come to expect from AWS. So then, how are they different? First, let's take a look at Amazon EKS. If you are looking for vibrant ecosystem and community, consistent open source APIs, and broad flexibility, then Amazon EKS is the answer. You can rely on Amazon EKS to handle the undifferentiated heavy lifting of security and operating Kubernetes at scale, providing you the highest security and resiliency for your application. And we recommend that developers adopting Kubernetes that want open flexibility should start with Amazon EKS. The next service is Amazon ECS. And what Amazon ECS really excels at is the simplicity it provides. With Amazon ECS, it reduces the time it takes for you to build, deploy, or migrate your containerized applications. And it also comes with AWS opinionated solutions for running containers at scale. And this also translates to various best practices of running containers already baked inside the service. As Amazon ECS and EKS are the container orchestrators, they still need computing instances to host our application. And I'd like to share with you about AWS Fargate, a serverless container and fully managed data plane that you can use to run your application. Both the ECS and EKS, they are able to run containers on Fargate. And why does it matter to you? Simply because with Fargate, it can provide a significant operational savings. Why? Because with Fargate, it frees you from having to manage any of the underlying infrastructure, and it also comes with improved security. And Fargate is running on serverless, so you can focus building on your product and not the infrastructure. And now you know the general landscape of container services on AWS. Just for a recap, on management layer, we have Amazon ECS for you who wants to deploy and operate your container application. We also have Amazon EKS if Kubernetes is your preferred flavor. And you have two options for hosting your containerized application. If you want to have granular control, you can use Amazon EC2. It gives you more control of your server clusters and provides a broader range of customization options. But if you want to focus more on your products and less on the operations, you can use AWS Fargate. AWS Fargate is a serverless containers. You have your app, define the task configuration, and let Fargate run it. Fargate lets you focus on designing and building your applications instead of managing the infrastructure. Now, in this session, we'd like to emphasize on how you can get started easily with your container application. So, we're going to focus on simplicity, but still giving you the rich features and powerful ability of Amazon ECS. And we're going to integrate with AWS Fargate serverless containers, so you can have more time building your apps and not managing your infrastructure. But the first question is how to do that. And that's where AWS Copilot comes into the picture. AWS Copilot is a CLI tool that will greatly help you to get started with containers. Not only is it the best tool for you to get started, but also give you the flexibility to extend your system. So in case that you are now starting with a simple application, or you want to extend your architecture into microservices, AWS Copilot has it all for you. If you're just getting started, you probably have all of these questions. How do I deploy my application? How do I extend the system? How do I integrate with CI/CD? And the list goes on. And that is why AWS released AWS Copilot. AWS Copilot is a command line interface, or CLI, that you can interact in your terminal, which enables you to quickly launch and easily manage containerized applications on AWS. AWS Copilot provides a simple, declarative set of commands, including examples and guided experience built in to help you deploy your apps quickly. And one of the advantages of using Copilot is that all AWS best practices are embedded into this tool, so you can have scalable, reliable, and extensible application with minimum efforts. So let's see AWS Copilot in action. In the next demo, we're going to deploy the application that we used in the previous demo and deploy it into Amazon ECS and AWS Fargate. Just a quick overview on what kind of app that we are going to deploy today. The application that we are going to deploy is a simple application to return HTML based on the Markdown text that we pass as input. So the application will convert the Markdown text into HTML using HTTP post method. We're going to use AWS Copilot to deploy our application, and at the end, we're going to have an application load balancer with a public address, which will be connected through AWS Fargate service, where our application runs inside the Amazon ECS cluster. Let's jump into the demo. In this demo, we'd like to show you the capabilities of AWS Copilot to deploy your application. This is the source code of the application. The application itself is written in Python and using Flask framework. For the same endpoint, which is root, I have defined different processes for get and post method. For every request to get method is simply going to return OK, and this endpoint with get method is mainly used for health check by ALB. The other method, which is post, is going to process the Markdown text and returns the HTML response. I also have a Docker file that is going to be used to deploy the application. This Docker file uses Python 3 as the base image and is going to install the requirements, running on port 9090 and run the application. At this stage, I already have a test environment properly configured by AWS Copilot. If you're wondering how to build environments with Copilot, I will show you in the next demo. But for now, we already have the test environment. Then all I need to do to deploy the application is by running command copilot service deploy along with the service and the environment name. And once it's finished, we will get the endpoint. Cool! Now let's test it out. I'm going to test the endpoint using curl command. With this curl command, I'm sending a request with post method along with the input using text as the variable name. The value of the text input is a text in Markdown format. And we get the results. As you can see in this demo, AWS Copilot makes it easy to deploy application into Amazon ECS and AWS Fargate. As you develop your applications, you will certainly add new features. And most of the time, new features also require integration with specific AWS services. For example, how if the Markdown service API needs to integrate with Amazon DynamoDB to log all the requests converted from Markdown to HTML? So how can we do that? There are two ways on doing this. If you need to integrate with services that already integrated with Copilot, such as Amazon S3, DynamoDB, or Aurora Serverless, you can use Copilot storage command. But how about other services? You can easily integrate more AWS services with your applications by adding a CloudFormation template into respective add-on folders. Copilot will pick that up and provision the resources as well as integrating the IAM role. Wondering how all of this works? Let's jump into the next demo. Okay, so now we have our API app deployed, but it needs a database so we could log all the requests. Let me guide you for a quick walkthrough for the source code. This is the app.py file, the main file for the API application. I have added a new function which is called as save data. This function will save the request this application received into a DynamoDB table. And if we go to the main function, you see that I have added a line to call the save data function. Our code already integrates nicely with DynamoDB, and what we need is the DynamoDB itself. So let's run Copilot storage init. Once we run this command, it will ask us a couple of questions, like storage type. In this case, we choose DynamoDB. Then the resource name, partition key, and others. Let's finish this process. Okay, so it's done creating the manifest. And you can also see the environment variable name for the DynamoDB table that we can use in our code to define the object for DynamoDB table name via the environment variable. So let's change the table name by using the value from environment variable. Okay, so now the application should connect to the DynamoDB properly. Next, manifest file. To find the manifest file, you can browse to the add-on folder. As mentioned, if you need to integrate your applications with other AWS services, you can create AWS CloudFormation template in this folder. Let's take a look into the manifest file. This is how the manifest file looks like. It's a CloudFormation template, and in this case, it defines Amazon DynamoDB for our application. If we scroll down to the end of the file, you see there are two outputs, and one of them is the IAM role. And this is important, and I hope you don't miss this part, because this IAM output will help Copilot to inject into your application so it has sufficient permissions. All right, at this stage, we don't need to change anything. So let's deploy this DynamoDB integration. To deploy the application, I just need to run Copilot service deploy and add the service name. This will take a while, so let's wait until it's finished. All right, seems the deployment is finished and we have all required resources, from DynamoDB to the IAM role attached to our application. Okay, so there's no issue, which is good. I want to check if the DynamoDB is created, so let's go to the console. This is my DynamoDB console, and if I filter by the name, I can see there's one DB created. Now if we run the API endpoint again, it now will log the data into DynamoDB. So let's go to the DynamoDB console to see if the last request is logged properly. Okay, so our application now integrates nicely with DynamoDB, and we can see the last request is in the database. And this is how you integrate your application with other AWS services using AWS Copilot. In the previous demo, we have learned on how that we can use AWS Copilot to deploy our application. Now, when it comes to modern application, one of the best practice is to implement CI/CD as early as you can. And CI/CD gives you benefit in the long run as it will increase your development velocity. So in the next demo, we're going to build a release pipeline. Whenever we push our changes into our Git repository, it will automatically build the image, push to the container image repository, and deploy to specific environment in Amazon ECS and AWS Fargate. It's not as hard as it seems. In fact, with Copilot, it's simple and straightforward. So let's jump into the next demo to implement CI/CD with AWS Copilot. In this demo, we're going to create a release pipeline for a single environment. We are going to use the application that I used in the previous demo. Before we're going to create a release pipeline with AWS Copilot, I'd like to show you how to create an environment with AWS Copilot. To create an environment, you can use copilot env init command. Copilot env init creates a new environment where your services will live. Copilot will guide you throughout the process and ask you a couple of questions, such as the environment name. In this case, I name it as test. And also the name profile to specify which AWS account and region I'd like to have our application run the environment. I will use my default profile for this demo and just let it finish the process. You can also use various flags provided by AWS Copilot to create environment. For example, you can also import existing resources like VPC and subnets to your preference. Now, as we have an environment for our apps called test, the next thing that we need to do is to deploy our application in test environment. To deploy our application, we can use Copilot service deploy command. If you didn't specify any flags, Copilot will ask you a couple of questions so it understands how to finish the process. Now our application is deployed. Let's check the application by running Copilot service show. Again, if you didn't specify the information with flags, it will guide you throughout the process. And this is something that I really like, as it is quite intuitive. Once we have the environment built, we now can check the status of the environment using Copilot env show command. This command shows information about particular environment. Some of the information includes the region and account of the environment, the production info if the environment contains production services, and also the services running in the environment. You will see that we have our application now running in test environment. Let's try to test it out. This is a simple application that's going to convert a markdown text to HTML. And if we do a simple curl command using post method along with the text variable, we're going to get the response in HTML. And this is good, since this means our application is running properly in test environment. Next, let's try to create the release pipeline with AWS Copilot. To create a release pipeline, all we need to do is to run 3 commands. First, Copilot pipeline init. The second step is you need to commit and push all changes to our GitHub repository. And the third step is to update the pipeline configuration by running Copilot pipeline update command. Let's do them one by one. Let's run Copilot pipeline init. This command will not create your pipeline yet, but it will create manifest file that will be used to create your pipeline. You can find those manifest files inside the Copilot directory. There are 2 new files generated by Copilot. They are build spec and pipeline YAML configs. Let's go through each of them. Build spec file contains the instruction for building and publishing your service. For most cases, you can leave the build spec file as it is. But for some case, you might want to run additional commands and you can add them to the build spec config. As for the pipeline file, this file contains instruction on how code pipeline needs to retrieve the source file, which environments you want the pipeline to deploy to. Same with other manifests. If you made any changes to these 2 manifests, build spec and pipeline, you need to update the pipeline with Copilot pipeline update. Now let's commit and push the files. Then we can instruct Copilot to integrate this pipeline with Copilot pipeline update, which will let Copilot to integrate with AWS Code Pipeline and AWS Code Build. In this stage, if you're using an external Git provider like GitHub, Copilot needs to create the connection and we need to update the pending connection as a way to approve it to make it available for use. Let's wait. We can also check the end result of our pipeline in the Code Pipeline console. This is the visual representation of our pipeline. You can see that we have 3 steps here: source, build, and deploy. So let's get back to our terminal and make some changes to our application to see if the pipeline works as expected. What I'm going to do now is to add environment variable into the application and retrieve it from the application. To do that, I need to open the service manifest file. add the environment variables for test environment. I'm going to name it as running env, and with value this app is running on test environment. And open our application file, and add the environment variable as the part of the response. And that's it. Now what I need to do next is to git push my changes. And now we can see the status of our pipeline with Copilot. And it's currently running. Let's wait until it finishes processing. And our application is deployed successfully. Let's test it out. To test this application, let's find the URL of the application by calling Copilot service show. And we also see that we have the environment variables from the test environment. And if we test it using the curl command, we can see that we got response from the application. We got the HTML response from the Markdown input, and that means our application works. And that demo ends our session for today. If you want to explore more about AWS Copilot, here's a few of additional resources for you. First, the AWS Copilot product page, which holds important information about the concept and the complete set of commands that you can use to get started. Then, we also have a free online workshop that you can follow to try all the demos presented in this session. The online workshop is hosted on GitHub, and feel free to file issue if you have any questions. And for you who want to dive deeper into more architectural patterns that you can build with AWS Copilot, you can go to www.copilot.rocks. In this site, you will find how to implement architectural patterns, from how to implement service discovery to architecting pub/sub patterns, along with codes and step-by-step guidance. And also, AWS Digital Training offers free digital on-demand courses which can help you learn skills and cloud services. Interested? You can register directly at aws.training. We really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think. So that's all for today's session. Thank you for your time. Hopefully the content and demos presented in this session help you understand containers offering from AWS and how you can build, release, and deploy your applications easily with AWS Copilot, Amazon ECS, and AWS Fargate. And more importantly, for you to enjoy more and having fun building apps with AWS. Also, if you have any questions, feel free to contact me on Twitter or LinkedIn. And once again, thank you so much. I'm Donny Prakoso, and happy building.